This module examines break-even analysis. Break-even analysis is a common financial tool used to determine the level of revenues required to cover all of the relevant fixed and variable costs, and to set the amount of fees or user charges to recover the full cost of a service. Break-even analysis uses the concepts of volume, cost, and pricing to provide useful information. Volume is the number of units of service, such as shots given. Cost refers to the total of both fixed and variable costs. Another module will go into more detail on fixed and variable costs. Pricing is the use of volume and cost to determine a price for the service. That per unit price could be charged to a client or used as justification for central government funding or for donor funding. In using the cost-volume relationship, you'll be able to determine the break-even point, which is the level of activity that generates total revenues equal to total expenses. Break-even units, which are the number of units that must be produced and sold to generate enough revenues to cover all costs during the period. And finally, break-even revenues, which are the level of revenue to cover costs during the period. A basic application of the cost-volume relationship demonstrates that if 1,000 units are sold at $4 each, there are total costs of $4,000. Then, break-even units will equal 1,000. Break-even revenues will equal 4,000 in revenues, and the break-even point is equal to 4,000 in costs. The volume cost price relationship lends itself to a little more complicated set of equations. Let's explore them. Each of the letters in the equation stand for certain variables. Y means profit target, the amount you want to earn above costs. TR stands for the total revenues. TC stands for the total costs. Small letter p means the price charged. Small letter q stands for the expected or required sales quantity. Small letter v refers to variable costs. And FC stands for fixed costs. Now we use those abbreviations for these 5 equations, starting with one relationship to discover another one. Thus, it's really a step-by-step way to use one equation to solve for another. Equation 1 says that profit equals total revenue minus total costs. Equation 2 shows how to compute total revenue, which equals price multiplied by quantity. Equation 3 shows how to determine total costs, which are equal to the fixed costs plus the product of variable costs multiplied by the quantity. Equation 4 simply restates equation 1 by inserting the variables from equations 2 and 3. In other words, profit equals price times the quantity, which we found in equation 2, minus the result of equation 3, which computed the total costs. Total cost was the fixed cost plus the product of variable costs multiplied by the quantity. Equation 5 just simplifies equation 4. It says that profit equals price times the quantity, minus fixed costs, and minus the product of variable costs times quantity. We have a few more equations to define before we use them in an example. Note that a break-even point implies that profit equals 0, or where revenues just cover all of our costs. Restated in abbreviated form, it's y equals 0. Equation 6 inserts 0 as P, or profit, in the prior equation 5. It reads as the break-even of 0 profit is equal to the product of price multiplied by quantity, then minus any fixed costs, then minus the product of variable costs times quantity. Equation 7 is just moving the prior equation around using algebra to solve for fixed costs. Therefore, this equation now shows that fixed costs are equal to the product of price times the quantity, then minus the product of variable costs times the quantity. Equation 8 moves the prior equation around to say that fixed costs are equal to quantity times the result of price minus variable costs. Equation 9 goes the next step to solve for quantity, which is fixed costs divided by the result of price minus variable costs. Wow, that was a lot of algebra. So now we can catch our breath. But at least we now have various equation relationships to use in doing break-even analysis. We can now use those volume cost price relationships to determine the break-even point. First, we have to define or provide a number for variable costs, for fixed costs, and for the price to charge. Plus, we can even add in a profit target as part of fixed costs. Then we plug those numbers into the formulas to do break-even analysis. Here's the example. Assume you are the head or principal of a local school. You want to teach the children about community involvement by having a bake sale to raise money for HIV testing. The children will bake small berry pies in the kitchen of a local restaurant. You want to know how many pies the school will have to sell in order to break even. Each pie will be sold for $4.50. Plus, the school's goal is to earn $400, which is the profit target, for HIV testing. Here are the estimates for the various cost items for conducting and marketing the bake sale. Kitchen rental is $300. Kitchen cleanup costs are $150. Advertising costs are $75. Pie ingredients per pie is $1.10. Disposable aluminum pie tins are 20 cents per pie. Disposable utensils, including 2 forks and 1 knife, are 15 cents per pie. Now we can use those assumptions in a series of formulas that we derived earlier. So using these assumptions, we find that total fixed costs are the $300 kitchen rental, the $150 kitchen cleanup costs, and the $75 advertising cost for a total of $525. We then add the required profit target of $400, which makes a total of $925 in total fixed costs. Variable costs per pie are $1.10 for the ingredients, 20 cents for the pie tin, 15 cents for the utensils, totaling $1.45 per pie. The price to be charged per pie, we've already said, is $4.50. Now let's get into our equations. We solve for quantity as equal to fixed costs, which are the $525 plus our required profit of $400, for a total of $925. That's divided by 3.05, which is the result of the price of $4.50 per pie minus the variable cost of $1.45 per pie. Since we can't make a fractional pie, our result is rounded up to 304 pies. We then determine total revenue as the price of $4.50 per pie times our quantity of 304 pies. That produces total revenue of $1,368. To compute total costs, we have to back out the profit target as part of the fixed costs, so it simply goes back to just $525. After this change, we have total costs, or TC, equal to fixed costs of $525, plus the product of variable costs of $1.45 times our quantity of 304 pies. That calculation results in total costs of $965.80. Y, or profit, is then the total revenue of $1,368 minus the total costs of $965.8, which produces a profit of $402, which is extremely close to our target profit of $400. The difference is due to having to round up our quantity to the nearest whole pie.